Yeah, we got a couple more coming now.
Live streaming is on.
And we're live. Um, are you ready, Nader, or Anash can do introduction?
Yeah.
Yeah.
I'm happy to
I think
start
people
whenever you
just
are.
pop in like slowly, so they
Yeah.
shouldn't. But an introduction. We are DIN, Digital Identity Nordics. We are not trying to replace Identity Foundation in any way. We're just trying to make sure that the Nordics are catching up with everything. Nader here is working for a company from New Zealand, and they seem to have really caught the gist. There's identity union in New Zealand or Australia. Do you know about it? That kind of thinks about
Mm-hmm.
this stuff. So I just believe that the Nordics has a lot of has somewhere some steps to go on this, and that's why this organization has started. And then we are doing these informational sessions to be able to showcase what the world is doing when we're discussing with important actors. So DIN in itself are not making anything special, but we are networking and putting the needed people together, and also trying to get research into this matter. So we're talking with the Norwegian University to get a couple of research applications going, and also together with a couple of identity brokers in Norway. So exciting stuff happening. But we're here together with Nader. And just to say that this is an informal session, so I will probably just ask questions when we can.
Perfect.
So if you kind of don't see our screens, I guess we can just say, hey, I have a question, and we can just cut out. But introduce yourself and we can get started.
Awesome. Thank you for that, Snow. So my name is Nader Helmi. I work with Mattr in New Zealand. As mentioned before, I'm happy to join you all here at DIN, and I'm excited to learn a bit more about what you guys are up to. Hopefully that'll come about naturally in the sort of Q&A. Very much kind of a mutual interest here. So let me share my screen and we can kick off. Can everybody hear me okay?
Yeah.
Perfect.
Or at least I guess I cannot speak for rest, but I guess for rest is all good.
Yep.
Awesome. And can you see my screen?
Yep.
Was it an affirmative? Awesome. Okay, so we'll just kick off here. As mentioned, Mattr, we're based in New Zealand, and what we do is we ultimately build infrastructure for verifiable data and digital trust. We work both locally and globally within the standards communities and partner organizations, as well as with customers to solve some of the historically difficult challenges around things like digital security, privacy, and data verification. So just a bit of an agenda for what we'll go through here today. We'll start off talking about the standards that are out there and Mattr's general approach to kind of building things out in the community, if you will. We'll look at selective disclosure, both in terms of what is the problem that it's intending to solve and what are the different solutions to kind of accomplishing that. Then we'll narrow in on a particular solution or a set of solutions around JSON-LD BBS plus signatures, which we believe have a lot of promise and is something that we've certainly invested in from our perspective. Then we'll cover off a bit around Mattr itself in terms of our products and our platform and what it really aims to accomplish, and then open it up to a bit of a Q&A. So hopefully it's just organic as we go, and we'll leave some time at the end as well.
Perfect.
Feel free to interject or jump in whenever something feels relevant. So, as mentioned, at Mattr, we tend to say that what we focus on are three key innovations. The first is around verifiable data and the ability to really have context around that data and share it across contexts. That is obviously verifiable credentials as the standard are very important to the decentralized identity community, and and we very much kind of hold that same principle in mind. Decentralized identities or identifiers. We use identities because it's a little more friendly oftentimes. And this is really about giving users the ability to have more control, more agency over their online personas, right? And again, enabling that portability in connection with data and other kinds of important information that end users want to keep.
Yeah.
Want to keep
Today you
secure.
guys support multiple DIDs, right?
Yes, that's right. So we support multiple DID methods. We consider ourselves DID method agnostic. We haven't built or designed our own DID method. We sort of take a look at what's out there and try to find the ones that are bringing unique things to the table. So, for example, things like, we'll look at DID web, DID ion with things going on inside tree, DID key, although a very simple method we think is very powerful. So we can get into that. Certainly, I think, as we go on, as the latter half, I think suits for that kind of discussion. But yeah, we definitely try to take a sort of a modular or like agnostic approach, especially when it comes to that kind of critical infrastructure. And the final kind of innovation here is the idea of user-centric cryptography, which really ultimately is the idea of cryptography that's made simple to use, right? Historically, cryptography has provided the backbone for trust on the internet, but that trust has been really only able to be captured by really high value interactions and really high value sort of actors, right? And it hasn't been historically something that end users, especially like your average Joe who's logging into some service or app online, certainly doesn't have isn't afforded some of those same kind of assurances and guarantees. And what we think is really exciting about this new model is the ability to make a lot of powerful cryptography and cryptographic techniques really simple and easy to use and put them in the hands of users, of course, while educating them about some of the practicalities and responsibilities, but ultimately trying to keep it simple, accessible, and easy to use. So our approach to to solving problems in this space is threefold. We kind of take this this cyclical approach, which ultimately is about we have this, on the bottom left here, we have the idea of the community itself. So we have all these different standards, organizations, and sort of consortiums of organizations working together on hard problems. And that is really where a lot of the sort of innovation and bleeding edge kind of technology is driven out, right? So we also work with the Department of Homeland Security Silicon Valley Innovation Program, which I'll go over a little bit more later on. And we work within a number of these standards orgs like W3C, the IETF, the OpenID Foundation, to really kind of build bridges between these different technologies, show up in a way that is ultimately trying to learn about what is out there and how we can sort of bolster what's already existing. And in the rare cases where, there isn't a solution for exactly the problem that we're trying to approach, raise that in the community and develop it out in the open. So we believe that's a really important kind of step. And then we have sort of the next phase is typically the, prototyping and testing of those ideas that are incubated in the community in kind of more of a practical environment. So working with, other organizations and partners to really prove out, given a distinct set of requirements that are clearly articulated, how does the technology function? What are its strengths? What are its weaknesses? And how can we kind of use that to refine what it is that the solution is ultimately offering? And finally, we kind of wrap that all up in our product. And our product is really meant to be sort of a modular and extensible way to get involved and use decentralized identity tools without having to be an expert in all of the sort of nuances and discussions going on in the community, right? So using DIDs and VCs in a scenario agnostic way is really important to us. We have Mattr 7, which is our configurable platform, and we'll go into a bit more later on what that looks like and how that shows up exactly. And so we are constantly kind of adding new features, and selective disclosure is a really important part of our product. Something we really believe in, kind of has general extensibility across the board, and most things you'll see end up in this product category are generalized solutions, right? There are things that can be applied to a number of these different scenarios, and then ultimately that work in product and the feedback from our customers feeds back into the community, right? Because we have then we have sort of our completed the cycle, if you will, or one round of this cycle, and we have more insights about what it is that the standards and technologies do well, what it is that they don't do well, what are the missing gaps, and we think that,
and I can confirm by also been talking to you guys and actually gone through the Mattr 7 tutorial that it is very, very extensible and flexible, which kind of allows you to put it in. It doesn't take a lot of predefined notions of what's going to be what. It just uses standards and important web standards that allows you to go out and do SSI in a very nice manner.
Awesome. Thank you. I appreciate that. We try our best, and I think the to your point, just to kind of that's kind of a good transition for me. We have this triad, as I mentioned, this cycle that really helps to inform everything we do in both product and community. And then really what we think is critical to sort of wrapping around this approach is the proper education and understanding, which is, we believe, is just as important as kind of these new tools. Even if the tools are designed to be simple and they're designed to be easy to use and extensible, and as mentioned, not require a lot of prior knowledge or prior art, it's important that folks really understand the new things about this model, right? We don't want to mystify it in terms of treating it as a black box, and it's it's a new technology that has all these shiny properties, and we're not going to tell you how it works exactly. Just trust us. We kind of take the opposite approach, right? Which is kind of coming at these things from first principles, trying to describe them and communicate them in a way that makes sense to the stakeholders that ultimately really care about this stuff, and then offer them the tools so that they're equipped to sort of solve the problems that really matter to them, right? So I'll also kind of give a highlight of some of the content and stuff that you can check out online here, but this it goes from things like concepts, papers, essays, tutorials, dev resources, documentation on both on GitHub repos and documentation of our product, and so we consider these kind of vital tools in sort of building the decentralized identity ecosystem in the market, if you will, and getting more good attention to the work that's happening in the space, not only at Mattr, but obviously across the space. There's a lot of incredible stuff happening.
Absolutely.
So now we're going to transition a little bit into diving into the problem at hand, which is, selective disclosure is ultimately a solution to a problem, right? But what is that problem? And the problem ultimately is that when designing any system that involves handling the personally identifiable information of end users, it's important that we kind of take the approach of trying to minimize the data that's disclosed in any given interaction. And the reason that this is important has to do with really the sort of contract between data subjects and relying parties, right? Which is, I think, largely been an unspoken or sort of unwritten kind of relationship thus far in the internet, where data subjects have been the collateral or an afterthought kind of for digital systems that are trying to enable access. And now that we have kind of some of these new tools, we want to reconceptualize the problem. So when users share information about themselves, they ought to be able to choose what and how much they share on a case-by-case basis if they would like to. And the relying parties that receive this information, they still need to be able to maintain a bunch of these really high integrity assurances, and also know a number of things about the information's origin and its provenance, right? So how do we accomplish that in a really kind of transparent fashion while protecting ultimately the needs and the rights of end users? So user privacy is obviously a really I think rich and complicated topic, but the approach generally has been to try to allow users to share only the information which is strictly necessary for them to proceed in a particular context. And this may seem
And to
Go
also like one important thing is that often an interaction might just need say I want to have a verified driver's license. It doesn't need your information, right? So a lot of the interaction we have online just needs to know that you are a holder of some kind of credential, but don't need to know the details of it. And that's what this is all about, which is kind of very, very important case, because people think exchanging data means exchanging a lot of data, but it just means that we need to come to a point where we're able to exchange verifiable data, but not disclose that data.
Totally. Yeah, I think this is a big shift, right? Because as you said, we're so used to and I think conditioned to the idea of, oh, well, I need to share a bunch of data for very simple things like, being able to prove that I'm over 18 or prove that I'm over 21 or alternatively being able to just, prove that I went to a certain institution, right? Or that I got a certain degree. We are often kind of conditioned to train to sort of share our entire set of credentials around that, right? So I might share my entire driver's license or my, entire sort of educational record. When in reality, what's needed is more of a targeted thing, right? And the reason that we overshare is because we thus far haven't had these verifiable tools which allow us to have high assurances around a fairly small amount of information. So
absolutely. And I just want to follow up with one example, and that's like everyone becomes an identity verifier. And just one really good example is that student discount.
Totally.
Why does the person looking at or getting when I'm showcasing a ticket for a train, for example, why should that person have to see any information about me? He just should know that I'm a student, or at least be able to trust that if he sees a green check of something that I am a student. But today you have to showcase him like your student proof, which basically showcases both your name, your date of birth, and where you're actually located and everything, which is unfortunate. Like in Norway, we even have this digital version, but it's still showing a name, it's showing where you went, and showing your face, because there's no way of matching these digital verifiable things as of now.
I wanted to add to that. So in the case of, for example, like a student ID, one of the issues is like we have like a key, like the Oslo key to get into like renovation state, to get rid of your trash, and like so you need some sort of mapping from the credential to a face or from the credential to a name, which can, because otherwise you just have like, well, here's a student ID. That was one thing, and the other thing is like, for example, with age verification, you just need to prove you're over a certain age, and not your date of birth. And so the question is, well, how the only way that I can think of that you can do that is that the issuer that you are requesting such a credential from issues, one stating that you're over 18, one stating that you're over 21, one stating that you're over 30, or et cetera, and that you have like multiple ones that you can. Are there other ways?
Yeah, I mean, I think one of the really important emergent features of verifiable credentials, at least in the implementations that we tend to focus on, is the ability to do authentication and binding in the issuance process. So, typically, I think we might be used to in the what we're typically calling bearer credentials. And a bearer credential is a credential that is not really attached to any specific person. Whoever holds that credential essentially is able to verify it, right? But it doesn't tell you anything about the person on the other end of that credential beyond the contents of the claims, right? But what issuers can do is do, excuse me, what's called a binding in the issuance process. And that binding may use some kind of biometric, or might use some kind of liveness test, and there are other methods as well to in the issuance process. It's in a way of the data authority that's issuing these claims to really make sure that they're doing so to the right entity. And when you have that assurance, then when you represent that credential, you have that binding present, and that provides an extra sort of layer of protection there, and knowledge for the verifier, the relying party on the other end. So, we typically say the word, verify this credential or verify this presentation, but what you're actually doing is verifying a bunch of different things, right? You're verifying the integrity of the claims inside the credential. In the case of JSON-LD, you're verifying the semantic definitions of those claims. You're also verifying the source of the data. So the issuer that that initially kind of issued these claims, and you're verifying in many cases also a number of things about the subject as well. So it's actually kind of more of a ball of wax there, and you kind of do it in one step, so to speak. But it's important to draw out that different kinds of credentials give us actually a different set of assurances at that final step when we are verifying it for a relying party.
Yeah, and I guess we're going to touch upon more of these ways of doing it when we get to the BBS part.
Yeah, definitely. So kind of going on this theme, what we believe is one of the real innovations of verifiable credentials as a standard is this idea that it's introducing a layer that's between relying parties, or what might be referred to as verifiers, and issuing authorities. So typically these entities have really been in direct communication. If you look at things like OpenID Connect, it's essentially how it works, right? As the subject of some data, you might authenticate it to an OpenID provider as a client, but ultimately the entities that are interacting and speaking to one another via the protocol are the issuer and the verifier, kind of more or less directly, right? And verifiable credentials, the novel thing about it is like really putting the role of the holder on equal footing with these other roles, right? And it says now, as the holder of credentials about yourself, you have greater control over your own information, and you have some say over the way that you assert your identifiers, the way that you hold, and then ultimately the way that you present credentials, right? And that can be in combination with other credentials, and also, of course, using selective disclosure, and in many cases, combining those two things, right? So selective disclosure across multiple credentials as well. So that is, I think, an important thing to know when we're kind of going through this next bit is it's all really enabled by this new role that we have. And I'm sure this picture of the data model is, familiar to some of the folks in the group here. So some of the existing approaches to selective disclosure, and this is not an exhaustive list, but 3 options that we think are, quite prominent, that we've seen outside of the decentralized identity space, to be frank, and as well as inside. So this is kind of an overview of some of these solutions. The first one that we see happening, and this is a model that's been popularized by OpenID Connect, is the idea of just-in-time issuance. The idea of just-in-time issuance is that the issuer will be contacted kind of directly at the time of the request from the relying party, and they dynamically kind of are able to generate a tailored assertion, which is a subset of the information, right, that the holder wants to share, and they'll do so either directly or indirectly at that time of the request. The next solution that we see out in the wild there is that of the trusted issuer. So this is using a witness or a third party that exists kind of outside of the realm of the issuer or the provider and the relying party, and this trusted witness is able to mediate the information disclosure and provide some kind of guarantees along the way. And we'll talk about some of the drawbacks and the strengths of each of these. Excuse me. And then in the final bucket, we have cryptographic solutions. So they use cryptography, obviously, to enable the user to disclose a subset of the information from a larger assertion. And obviously, the completely different set of trade-offs than the other ones, because the cryptographic approach is more of an infrastructure, or sorry, it's more of a data model kind of approach to solving the problem, whereas the other two are more or less kind of infrastructure issues that require relying on other entities, right? It brings more parties, or potentially more active parties, into the interaction. So let's take a look at the first two a little bit more closely. With the just-in-time issuance, ultimately, one of the things that is really obvious is the idea that issuers have to be highly available, or another way to put this is always online. And the reason they need to be always online is because verification process could happen at any moment. And when that verification process happens, in order for the holder to get any guarantees around their data, and in terms of minimizing it and doing selective disclosure, they need the issuer to be present to be able to dynamically create that tailored assertion. Now, the other thing about this is that the issuer will also have, more or less have knowledge of when and where and how the holder is choosing to disclose information, which, as we have learned from, I think, a lot of the problems with digital identity as it exists today, that constantly phoning home to the issuer becomes an issue, right? It's a privacy issue, and it's not that holders have anything to hide necessarily, but just the idea that an institution or an entity or an authority that is the authority on some information about you doesn't necessarily mean that they should be able to see when and how you use that information across the board, right? So that's an important principle.
This is what's not been done today, right?
Yeah. Largely, yeah, exactly. And this is, like I said, is like close to what the OpenID Connect model essentially is doing.
Yeah.
Then we have the idea of a trusted issuer. And I think this is, we've seen so many different flavors of this over the years, but ultimately the idea is that, you're entrusting this third party to facilitate the interaction between the holder and the verifier. And, that might be fine, you say, if you're able to really kind of trust that third party, but it's not the most scalable solution in the world, because of the idea that every holder who would want just a basic privacy guarantee would have to entrust their data to a third party. And these third parties, as you might imagine, they become kind of honeypots, right? Or they're an attack vector, right? So, there's ultimately open up the surface area of the where your information can be potentially compromised. And Yeah, so they're not an ideal solution, but they will kind of get the job done in certain scenarios,
Does this
if need.
would an example of this be sort of like if I present the corona vaccination thing and then I tell you to go look it up with the health authorities, and then the health authorities are the trusted party, or how can you like provide an example of what do you mean by trusted issuer or trusted party?
Yeah,
Like who holds what?
yeah. So really, what we mean here is the idea that you have some, not the issuer itself, but a sort of separate party that would disclose like sort of part of the credential for you. So an example might be kind of like in the realm of education, and you show up to a bookstore, and instead of getting a tailored assertion from the university kind of last minute, which would be more of this model, you would be entrusting some, for example, like
Student association or something like that.
yeah, exactly. Yeah, some kind of trusted org to kind of vouch on your behalf, and that might work. And consortiums definitely have done this in the past, and that's why I said like we've seen different versions of this, and we also see kind of productized versions of this, frankly, right? So there's different ways to kind of manifest that, but ultimately, yeah, that's kind of the example there.
Cool.
Cool. So, as mentioned, the just-in-time issuance again, assumes the issuer is highly available. The trusted issuer, you have that potential for third-party PII leakage, and then that leaves the cryptographic solutions, which we kind of view as sort of a native solution because it exists on the data model layer, and if done correctly, can be kind of a simple and flexible tool that we make available broadly to kind of anybody that wants to be able to use it. So, so solutions in this kind of last category typically make use of digital signatures and cryptography to dynamically allow users to produce privacy-preserving credential presentations. You may have sort of heard of this class of technology referred to as a zero-knowledge proof, or ZKP. Ultimately, the feature of this technology that people are really referring to is the idea that a prover can prove knowledge of some data without exposing any additional data. That may seem a little abstract, but what that means in the context of verifiable credentials is that as a holder, as a subject, I can be able to prove that I was issued this credential by a specific authority, and I can prove that the claims are valid while disclosing only a subset of them and making sure that the relying party is aware that I actually know these other values, I'm just not disclosing them. And that is really where the trust comes from, right? It's really the relying party is not only trusting, the piece of information you're sharing, but also they're trusting what you're omitting, right? And the idea that you have knowledge of sort of the broader credential, but you're not disclosing that in that particular interaction. So that becomes a really kind of powerful idea that we can use in a variety of different ways. But that is ultimately the cryptographic approach. So before we dive into any kind of specific technologies, I wanted to talk generally about, single versus multi-message digital signatures. Ultimately, what we mean by this is, when I say single message digital signature, this is the traditional digital signature model. So when you think message, just think it's anything that you really want to have integrity over, right? It's typically in our context, we're talking about a piece of information of some kind, right? So in the typical model, you have the private key and the public key of an issuer, right? And the holder might also have a private key and a public key as well, but we'll kind of put that aside for now and talk about sort of the credential and the way that it's issued, right? So in the traditional model, the issuer is able to just sign the message using their private key, and that produces this signature, which is ultimately what's shared in the credential. And so in order to verify that signature, what you need on the relying party side is you need the original message, right? The thing that that they're trying to communicate to you, the public key of the issuer. So not the private key, but obviously the public component of that key, and that signature that they produced. And using these inputs, you can ultimately validate whether the signature is, is indeed, positive or negative, or it's true or false. Then we have a different sort of class of digital signatures, which are called multi-message digital signatures. And the main difference, as you might kind of have noticed already, is that instead of signing a single message, we're now signing an array of messages. Now, why this is useful is that we don't have to apply, and especially in the context of verifiable credentials, we don't have to apply the signature over the entire credential, and that's it. Because when we apply the signature to the entire credential and that's it, it means that verifiers are kind of hamstringed, right? Because of the way that it was issued, they can really only verify, a presentation that is disclosing, the entire original credential. But when an issuer is able to sign an array of messages, we can think of each of these messages as, in this context, as a credential attribute or a claim, right? So because every claim is being signed, it allows these claims to be verified kind of individually on the other end, using, again, the same kind of sets of information, but now with the added ability of having this array of messages. But on its own, again, we haven't achieved any selective disclosure yet. So, but that is kind of a major difference there between single and multi-message digital signatures. Now, multi-message digital signatures also add these new functions, and this is really where the selective disclosure comes in. And these new functions are derive proof and verify proof. So in the derive proof model, we are, it's as you might kind of see here, we're doing are really, looking at this model where you have the messages, the public key, and the signature. We're able to do that in a slightly different way on the holder side, right? So deriving the proof is the ability to kind of indicate which attributes you're disclosing and which you're not. Combining that with the public key of the issuer, as well as the sort of signature that we produced in this step right here. And that ultimately produces this proof. So then this proof can ultimately then be verified by somebody using just these elements, right? Which is the messages that have been disclosed with certain ones omitted. Again, the issuer public key, and then that new proof that was generated. And using that, they're able to validate that that the end user knows all of the messages that have been signed. They know the full array, but they're only electing to disclose a subset of these messages. So that is kind of the novel kind of function that's introduced by multi-message digital signatures. And as you can see, what's happening here is that you have the sign function, and this derived proof builds on that sign function, right? It adds kind of an extra layer, an extra step. But in terms of user experience, it's actually quite performant, and it happens kind of all in the background under the hood. So users are able to kind of trust that process is happening.
So if we put this in an example,
yeah. So
when you kind of go to a web page, that web page is requesting proof of something from you. That is the point where you get their public key, right? So you're able to derive the proof that you want to derive to them, because you're not deriving that proof from your private key, but you're deriving it from the public key, because it just kind of make it put in context where this proof generation is happening, because it should happen on the side of the data controller, and not on the side of the
so let's take the same kind of bookstore example, except it's an online bookstore, right? And so at some point earlier in kind of the in the process, you have the issuance, where and this is really this step, and this is where your educational institution will, produce your education credential with a signature over it, and they sign it here, right? So now you, as a user, you have that. And then you show up at the bookstore, the online bookstore, and they need proof that you're a student. So what you do is let's say you hide messages 1 through 4, and you only disclose message 0, which is really just your like a yes or no Boolean that you're a student, right? Let's just say that there's a claim in the credential that says that. And so ultimately, when you're about to kind of share this information with the relying party, this is the point at which you generate the proof. So you take the issuer public key, which means the public key of your educational institution, right? Which should be kind of it's broadly known, right? It's known to both you and the relying party. It's not private information by any standard, and many times we expect that, especially institutions like universities and banks, etc., will have their public keys, mostly published in registries that are widely available, right? So,
and also if it's going by a DID standard, it's resolvable because you have your credential, which has the issuer, which has the DID, which all have.
Yeah. Exactly. Yeah, you're making a good point there, and also, jumping the gun slightly, just because we try to keep these layers somewhat separate, right? So, a BBS plus signature, a multi-message digital signature, is a cryptographic technique that is sort of applicable outside the realm of DIDs and VCs. But yes, certainly, right? Like when we're talking about this in the context of credentials, we have, that resolvability. So yeah, as long as you have the DID, you're able to kind of retrieve that public key.
Yeah.
So yeah, so
the cool thing about this is also that you can have one credential with lots of data, and go back to Espen's example, like you don't need to issue 3 credentials to get 3 different data points. You now have a credential with lots of data.
Just quickly on this, so is the difference here that you have one signature that you can selectively show multiple messages as? So there's a difference between multi-message digital signatures and multiple single message digital signatures, which would require one signature per message. Is that the gist of it?
Yeah, totally. I mean, what you're referring to is something that we've also seen out there in the wild, which is saying like, hey, a solution to this problem is that we're just going to issue single claim credentials. The problem with that is that it exponentially kind of increases complexity, right? The more that you add claims that are into the interaction. So having these sort of bespoke claims also breaks the chain of how they were issued, if that makes sense. Like if a bunch of claims are issued at once, it tends to be a useful thing to know that, and to kind of have that information to manage from a holder perspective in one place, and from a relying party perspective, to be able to trace the root of trust for a set of information instead of for a bunch of different sets of information. So yes, in a sort of long-winded way, that is, I think, the key here is the idea that it's one credential, one signature that you're able to kind of create the proof over, and then using just that proof and the signed messages, you're able to allow a verifier to really know and trust the claims that you're making.
Cool.
Awesome. So now we're going to talk about BBS plus signatures a little bit. So BBS plus signatures, as I mentioned, they're a kind of multi-message digital signature. So it does produce signs an array of messages instead of a single message. And it's a kind of multi-message digital signature that uses what's called pairing-based cryptography. And the keys that we use to accomplish this, and in this case, is something called BLS 12381. And this is a cryptographic curve that is pairing-based. So without diving too much into that, I'm certainly, not a cryptographer myself, but I think a lot of us are able to use these tools while understanding some of the properties that they give us kind of on the other end. So one thing about the history of BBS plus signatures is that as a cryptographic technique, it definitely predates SSI and decentralized identity. And then as far as its history in this space in particular, it's been incubated as part of Hyperledger URSA since at least 2019. And URSA is a shared cryptographic library that is really use case and tech stack agnostic. So it's unopinionated crypto that is reviewed by cryptographers and sort of the experts in the community to try to develop some common tools that we can all use. Because as we know, it's not the greatest practice to roll your own crypto, so to speak. Instead, it's using shared cryptographic libraries becomes an important sort of resiliency and security characteristic of the network. And now BBS plus signatures are, can be characterized as sort of an alternative crypto approach to the CL signatures method, which you may have heard about as being sort of the long-standing approach that's incubated by the Hyperledger Indies Anon creds. So this is largely kind of deprecated at this point in time, but was the predominant way to do quote unquote ZKPs in the decentralized identity space for quite some time. And if we just look kind of at a glance at sort of the performance and size difference between a BBS plus signature and a CL signature, it's quite significant in many cases, right? Like we have like orders of magnitude in some cases, size difference, and that ends up leading to a lot of kind of important efficiency guarantees that make doing selective disclosure and preserving privacy easy, right? And I think that is one of the key insights of BBS plus signatures and the approach that we're championing is that if selective disclosure, if privacy is not made interoperable and is not made simple and is not made easy, it will likely not get used, right? And that's because we live in practical realities. We have, incumbents and legacy systems that have solutions to some of these problems, as kind of mentioned earlier in this chat. And so in order for it to really compete on a proper level, we need to make sure that we've kind of checked all the boxes and set this thing up for success. On the other end, we have, usability and sort of legal things to work through, but that's all, I think part of the process. Once we get over that initial hump of kind of, buy-in and adoption at that kind of lowest layer.
It's I love it. We are implementing as well, so I think it's really cool. BBS.
Yeah, we've had a lot of good feedback from implementers, and there's quite I would say a vibrant community around it now, in terms of different folks engaging with the linked data proofs work and using it in their own applications. And I'll mention a little bit later, like how some of the community is starting to converge around this. I think it's a really cool thing to see. So as a kind of a brief kind of touch on this, this topic, verifiable credentials come in different flavors, and without rabbit holing too much on this particular topic, because as you guys might know, there's also some formats which are not strictly VCs but are credential-like things, which exist outside of these two options. But let's just kind of scope this to the the verifiable credentials data model and the spec itself, the one from W3C, and that standard really introduces two different ways to represent a credential. One is a JWT, that's a JSON Web Token, and one is a linked data proof. So JSON, the JWT is sort of taking JSON and adding these signature over it. Excuse me. Whereas technologies. Whereas the link data proof is really producing a signature over JSON LD, so JSON link data. And this is basically a serialization of JSON that allows the person creating the credential to build on a common set of semantics that allows ideally for broader ecosystem interoperability. So what this means is that we have open data kind of vocabularies on the internet with things like schema.org that define a bunch of terms in sort of relatively standard ways. And so by leveraging that existing data vocabularies, we're able to define things in a way that they can be easily understood across contexts without and not just understood across context, but understood by machines as well as people, right? And so that becomes kind of a really critical thing in terms of designing the logic in these systems, because semantics just makes things easier. And semantics, I think, is a complicated word for a really simple thing, which is just what is the meaning of this data, right? What is the meaning when I say name? What do I actually mean? Am I talking about a first name, talking about a last name, a family name? And it's important because I think we take for granted that what we might term something in one context will be the same in another context, but as we know, even just from sheer kind of mistake, a lot of times that gets lost in translation, right? And so one of the real benefits of the linked data proof model is the idea of building on a common set of semantics. So that is the format that we're looking at when discussing BBS Plus signatures, because what we've defined is essentially a linked data proof crypto suite, which uses instead of RSA, uses the BLS and BBS Plus signatures instead. So we'll see that here in a moment.
I think that linked data I underestimated it for a long while until I understood it.
Mm-hmm.
But you can just take that example, like to be able to query for something rather than to be able to say, hey, what's your endpoint? Okay, what data are you going to deliver me? Okay, now I can read your data. It's just silly, because that we have this situation in Norway. We have this really gigantic data catalog, which has a lot of endpoints, and we try to build the semantics around what data you're supposed to deliver from your API. But in the end, we're just talking endpoints and not really the semantics, which we really want to get to. Like, give me your driver's license. I don't care how you kind of give it to me, but I need it in the format that we all agreed upon way back when we said the semantics of driver's license should be like this, and it should be verifiable.
Totally. Yeah, like the idea of being able to ask for specific things, it becomes a really powerful tool in our tool set, and cuts down on the number of steps, right? Like you're saying, that interaction that happens, that back and forth, what's your endpoint? And then I'm going to send you, a tailored message, and then you're going to ask me, what is that message about? And then I'm going to, clarify, and then you'll send me the information. It's a lot of sort of unnecessary steps, whereas we can simplify it in many cases by having kind of semantics at that lowest layer. So I think that's a big benefit, certainly, of this approach. I just realized I am probably, quite late on my time here, so feel free to cut me off if need be. I'll try to get through the rest of this as efficiently as possible.
I think we can run over. I will have to leave, but I will leave this recording and this room open, and I really want to listen to the rest of this. And then I know that Espen probably has a couple of questions towards the end, but if you have time, stay on, but you quit it whenever you want. But I have a hard stop soon, but I'll leave this recording and room open.
Awesome. So all that setup was for us to kind of get to ultimately the solution that we're talking about at hand here, which is JSON LD BBS Plus signatures. So combines all the things we just talked about, combines JSON LD and linked data proofs with a multi-message digital signatures, and specifically BBS Plus. And what that all gives us in in summation, is the ability to have really a highly performant and compact signature representation, and that it builds on an open world data model, so you're able to, leverage a lot of the sort of existing information in the world and reference information that is referenced by other credentials, which ends up being kind of having this network effect where you can create knowledge graphs of data that are interconnected. It's has those rich semantics without compromising on privacy, which is something that historically has been a really difficult trade-off to kind of accomplish. And they're self-describing, which means ultimately that no external dependencies exist. Excuse me, take a drink of water. And why this is important is it means that the credential in the presentation can just happen in a peer-to-peer fashion without requiring a bunch of infrastructure or requiring other parties to be involved in the interaction, which kind of simplifies things both from like a resource perspective as well as from just a solution kind of coordination or mediation perspective, if you will, right? Like, as somebody who's interested in solving problems, what are all the pieces that you need to have in place to kind of make the interaction happen? So in this kind of JSON-LD BBS Plus model, we're leveraging existing schema technology, so we don't need special schemas or credential definitions that are, for example, stored on a ledger. So we're now kind of that's why you may have heard BBS Plus signatures referred to as a ledger agnostic selective disclosure approach. Is basically you're able to obviously still use DIDs to kind of identify issuers and subjects, but you're not anchored to any ledger at all in terms of the logic of verifying or signing a credential, which ends up becoming like a really useful tool actually, right? Because now you can start to move these credentials across a bunch of different contexts without being worried about, does this context have access to this ledger? Do they have the tooling to be able to do that? And so this is sort of a really a highlight of everything we've talked about today. The security of digital signatures, the ability to have strong authentication and binding. This is sort of a general property of credentials that we're able to leverage. The semantic meaning, which is obviously really enabled in this case by JSON-LD, selective disclosure, being able to link multiple credentials together or unlink them if need be. And this last one is also an important one, which is being able to do revocation in a privacy-preserving way. This is admittedly a separate solution, but we can use it in tandem with JSON-LD BBS Plus, which just adds to the I think impact of this kind of technology in the market.
How would the revocation work?
It's probably a rich enough topic for its own talk, to be completely honest. But
skip it.
But just really briefly, cryptographic accumulators, basically. So BBS Plus signatures enables a way to do revocation using cryptographic accumulators, which is basically like a delta that is measured and then sort of computed on. And I'll leave it at that so we don't rabbit hole too much, but it provides a different approach to the maintain a registry model, right? And so that's another model that we see often, is the idea of issuers having to maintain a registry. And then, in order for someone to check, is this credential still valid? They have to go check that registry. And there's a whole spectrum of ways to do that. And
so
ways
almost
to preserve
you can check if it is a member of, the revoked, but.
Exactly. Exactly. Yeah, totally. So an example UI of how this might show up, and this is kind of an older version of our wallet, but I just wanted to show it here. So we have the credential attributes, and these are the ones that are being shared. And then you have some attributes which are not being disclosed, right? So you'll see things like title, description, organizer, attendee. You can choose, and this is ultimately something that in the UI you're able to choose, right? Which attributes. Yeah, excuse me. Which attributes are sharing and which you're not. And then we have this little sort of tip off in the UI, which says, hey, this is a credential with a different property, right? You have this ability to do selective disclosure, which allows you to share only the required information. I was gonna show this video, but I'll just briefly kind of pull it up here so you can see the UI. We'll skip over the issuance side of things and go straight to so this is an example of logging into like customs and immigration website to show that you have an appointment. So this is the actual presentation, and if you'll notice here, it's asking us, do you want to send the following information to this relying party? And you have this credential with this tick that says selective disclosure. And you notice it said preparing the list of claims to be shared, and then it produced this list, and this is really a function of the request. So the request can also specify, we're asking for these specific attributes, again using that power of JSON LD, and then you get this screen that tells you here's what you're sharing and here's what you're not. Yeah. So that is basically just there, but I encourage you to kind of go check out the rest of the video if you're interested. I also have a longer video end to end, which shows kind of how you go through the sort of even the issuance and verification process from using Mattr tools, and I've included that video as well for you all to check out later. And here I just wanted to mention sort of some signs we've seen around the community coming around BBS Plus, which are really promising. So one of these is that Evernym, who is a company that operates in the the SSI community and the decentralized identity community, who have been a really important player in kind of building some of the foundational technologies in this space. They typically have used the Hyperledger anon creds approach with the CL signatures, and they recently kind of had published this blog post around BBS Plus credentials after a number of IAWs, where they kind of recommend in that blog post that the community converges around JSON LD BBS Plus because it offers kind of a balance between a lot of these design constraints, right? Like folks want privacy, they want semantics, they want to be able to do things using a data format that folks can generally agree on. And it was really promising to see them kind of recommend that, and indicates a shift in the biggest player, using a different ZKP approach in our community, kind of indicating that they intend to, and hope that others do as well, kind of converge around that. We also saw two different groups kind of recommend JSON LD BBS Plus, and this was one of them was the Linux COVID Credentials Initiative, which published a paper on what they called verifiable credential flavors. And at the end of that paper, which I've kind of included the last bit here, is saying basically that this new model of JSON LD BBS Plus is something that folks can all rally around. And then similarly in the Good Health Pass, the blueprint there, they published, I think this last week, and in that interop blueprint, that was one of the components of that recommendation was to use this format as well. So we're seeing a lot of really positive kind of indications that this is being used to solve problems in a way that people find the trade-offs acceptable, which is I think ultimately the goal of this work, as I mentioned, was to make that privacy trade-off an easy decision to make, right? some kind of brief updates around BBS Plus. So there's a blog post here if you want to read kind of about everything that's been going on lately. But I mentioned these as three different sort of concrete ways to get involved if you're interested. One is that at the Decentralized Identity Foundation, there's a new working group that's just specifically around cryptography. And so in this crypto working group, it's being spun up, by us at Mattr, as well as a number of folks in the community. And one, I think probably the first working group item of this group will be the cryptography side of BBS Plus. So not the sort of linked data proofs, credential stuff, but the crypto side of kind of improving, the signatures as well as the revocation mechanism and all that good stuff. There's also the linked data proofs standardization, which is about to kick off at the W3C. So this is the signature suite, the crypto suite for BBS Plus signatures, but this is really one of the collection that will be standardized as part of that linked data proofs work, and that is really, I think, that working group, the proper working group that will produce the official standard at the end of this process is really just kicking off now. So if you're curious and want to get involved, it's, almost couldn't be a better time. And finally, the folks in Hyperledger land are actively working on sort of migrating or, making interoperable their CL signatures approach with this new BBS Plus signatures approach. And ultimately, I think moving more towards BBS Plus. So the folks in Aries and they're building the tools over there have started this work, and encourage you to kind of check that out if you kind of come from that context and want to get involved in that ability to create that interop. Finally, I'll just go over a little bit about Mattr and just introduce you to some resources that are out there for you to check out. We have our website and as well as our Mattr Learn site, and these are used to really provide additional context and show how verifiable information can help establish privacy and digital trust. Our Learn site includes concepts, and you see some of these here, like the idea of what is a web of trust, what is digital identity, a number of tutorials and tutorials and walkthroughs for all of the existing tools and products that we have, pricing as well, policies, and our API reference if you want to check it out and see kind of what the interface is that we, imagine folks using for interacting with all this stuff. I've added sort of a collection, a handful of resources and links I thought would be relevant for this group. So, this is a group of, essays and explainers, some updates from the community, video demos, updates on our product, and then tutorials that show you how to use some of the aspects of our product. Our product is, our main kind of focus is what we call Mattr 7. Mattr 7 really provides the sort of the foundational capabilities to allow anybody to build any application that makes use of this technology and leverages it to solve problems. So it's an extensible kind of SaaS platform. And we break the functionality up into three main groups that are part of the Mattr 7. There's the core, and this is like things that you might be familiar with, DIDs, VCs, messaging, etc. And these are the APIs that contain the sort of the bare bones, the building blocks needed to kind of the features needed to accomplish some of the to sort of solve some of the problems and accomplish some of the solutions that are that folks are interested in. We have extensions, which really are kind of higher level capabilities, orchestration, application logic that allow you to kind of use this technology in other domains. And our example here is the OIDC bridge. So we've built a way to use verifiable credentials over OpenID Connect and to actually use OpenID Connect to issue those credentials. And again, that's a an interesting topic, probably worth its own chat if folks are interested. Excuse me, apologies again. And then finally, drivers. And this is where we kind of have this pluggable layer at the lowest level, which allows us to provide optionality for the things at the higher layers, right? So this is things like being able to support different cryptographic suites, different DID methods, different storage methods. And so this allows our product to kind of be extensible over time, preventing that idea of vendor lock-in and enabling user choice, providing more tools and more education to make those choices. I won't go over this too much, but this is sort of an overview of a lot of the different features that we have in each of these buckets, as well as, we have developer tools that include like a mobile wallet to facilitate issuance and presentation of VCs, a JSON-LD linter, which is tooling and a CLI for checking the syntax of a JSON-LD credential, and sample applications as well that allow you to use our platform. And we use this infrastructure across a number of different use cases to solve common problems, basically. As mentioned, we work in the standard space, and we're proud to be active contributors in a number of different communities. We also joined the Department of Homeland Security Silicon Valley Innovation Program in October of 2020. And there we work with U.S. Customs and Immigration to deliver capabilities around essential work and task licenses during pandemic conditions, but also beyond that as well. And we have a number of work here that we've done around interoperability with other vendors across the decentralized identity space, interoperability testing via test suites, and a number of work around this VC-HTTP API, which is a common standard for defining issuance and verification APIs that can be used across a number of different contexts. So this is sort of just a collection of the different things that we do. Ultimately, are all to build bridges and break down silos, and using kind of open standards and these capabilities to meet people where they're at. Apologies for that. And yeah, with that, I think we'll wrap up there. If anybody's still online, happy to take questions.
So just like quickly, because I learned a lot about zero knowledge. Zero knowledge proofs was the my head's all right. So the question is, how are the proofs zero knowledge? Are they zero knowledge as in you issue multiple so for example, if I want to prove my age and I want to prove that I'm over 18, I'm over 19, I'm over 20, I'm over 21, et cetera, et cetera, et cetera, do I need one proof in that multi-message proof thingy per proof, or can I sort of self-certify that I am more than this number of seconds old or something like that? I don't know.
Yeah. So it's zero knowledge. Is not the best way to describe it. I think it's just a sort of a term that's caught on in the community to describe this technology. Because really what you're doing is it's a zero knowledge proof of knowledge, which sounds complicated, but really what it is the idea that you're proving that you know something without disclosing that thing. And so in this case, what that means is that you are able to really just kind of indicate which messages are being disclosed, and then create a single proof which captures the that information semantically. So it's not and you talked a little bit about the you have ability to control things like over 21, over 18. Those are what we call predicate proofs. And what a predicate proof is that it takes a claim. Let's say the claim is that I was born in 1990. And then what it does is that it's doing an evaluation. It's doing a predicate, which is greater than, less than, equal to. It's making some evaluation and saying, I'm not just disclosing, excuse me, this attribute, but I'm going to be able to kind of say this other information about this attribute, which is a distinct possibility. It's something we haven't implemented in BBS Plus signatures to date because of some of the design constraints that it introduces. It actually requires a little bit of extra work on the cryptographic end, which adds bloat to what's otherwise a pretty simple solution. And in reality, we think that the idea of a predicate and a predicate proof is actually less common than people think. We always kind of use the typical example: you go to the bar and you want to just prove that you're over 21. But there are other ways to kind of accomplish that, certainly in the issuance process, and at this stage we haven't found it a really compelling reason to introduce that additional complexity. And so we're waiting to see, and there's certainly other members of the community that might kind of care more about the predicate side and want to develop that out, but we find
I agree.
It's quite
you could probably get away with just issuing a couple of different H's in that example.
Exactly.
You don't need the granularity.
Yeah. Any other questions?
Yeah, maybe just a follow-up on this one. Do you think it's possible to use this kind of a zero-knowledge proof technology to make it harder for tracing some of the credentials that have, let's say I have been given some credentials and I'm kind of showing them. So because I'm reusing the same identity key for which the credentials were issued, multiple parties can start tracking me based on my public key, such that, they kind of track some activities that I do, right? Do you think there is some mechanisms or some things that would kind of help to improve this unlinkability, even though, one way is that I would have issuers kind of issuing me the credentials under different public keys, but that's kind of complicates, same as with the multi-message thing, right? So what do you think? How do you see this kind of being resolved?
For example, with the Corona Pass.
Yeah. Which you have to show everywhere, right?
Yeah. So the way to solve this problem typically is that instead of using a public key in the presentation as your identifier, it's possible to use something else, which you may have seen referred to as a link secret. A link secret allows you to essentially create a signature and have an identifier that is not attached to kind of the way that the link secret works is let me see if I can get this right. The way that the link secret works is essentially provides the ability to create signatures from the same identifier or from different identifiers without kind of disclosing those identifiers directly. So let me see if I can pull up an example really quick. It's one of those things we consider an advanced problem. But there is kind of a solution that we've explored and presented at the last IIW. So let me just pull this up really quick. And I can share screen again. Give me 1 second here. Okay. Yeah, so
with the Corona Pass, I think, it's going to be kind of hard because you hold up like a Corona Pass ticket, but it has to be tied. It is tied to your name, so they can track you by that. And then if it wasn't tied to your name, it would have to be tied to your picture, and of course your picture would probably have some sort of unique hash or something. So it's like a kind of hard problem to solve. Because you can't have the verifier. You can't sort of flash like in Mission Impossible, where you sort of flash them and make them forget you.
Yeah, totally. Well, excuse me. Yeah, when you disclose those other claims, you have the correlation becomes a lot stronger. But yeah, the solution, just to loop back, I misspoke there in saying that the presentation, you're not actually disclosing, you're not using an identifier. There's no globally unique identifier for the subject at all. What you're actually doing is using that link secret is really a private key, which is, you're using to authenticate and produce a signature, which can be evaluated, without disclosing this globally unique identifier, which the issuer knows you by, right? So, but yeah, there are other kind of things that come into play now when the credential itself is, has PII in it, right? And then depending on your requirements, it might kind of defeat the purpose of the kind of blinding or masking that you're attempting to do. Any other thoughts, questions, clarifications?
It was a really good talk. Thank you very much. I really in-depth and kind of a broad overview of all the related technologies. So yeah, it was great. Thanks.
Thank you. Appreciate it. Apologies. As you can tell, I'm a little feeling a little sick today, but I figured I'd power through because I really wanted to meet y'all. What we didn't get to do is I'm really curious to hear more about what the folks that are here are interested in, what you're working on. I think also, Espen, I think you were trying to talk earlier, but I think maybe you're on mute. So, but anybody really, if you have, I'm curious, and maybe we can schedule another call, or I can come back in your next meeting. How often do you guys meet? Monthly, weekly?
Yeah, about once a month or something like that. And Snow is the one taking the initiative and leading on, I think. No, I was trying to talk earlier. I just like so I think the next session is on like Europe ID project, and I was wondering, that's a topic of its own, but will they follow a standard, and will they enable this sort of selective disclosure that you're showing here? Because that'd be really neat if they do, and really sad if they choose like a proprietary kind of, because we have that in Norway. You can we have a digital driver's license that you can show to the police or to the road authority. So it's kind of useless because you're showing the issuer the proof, and they're checking, like they're the issuer, and so they have the data available to them, and you're just, what's the point?
Yeah. We see a lot of those initial use cases where the issuer and the verifier are one entity. Mm-hmm. It's basically replicating existing systems, right? But it can be used as a proof of concept, I think, to get people thinking on the right track. So I think you're referring to the EU green certificate, right? Or is that, there's so many different initiatives, so I just want to make sure.
The other day I saw something about like the European sort of digital identity wallet system, but it's new to me.
So
the new version of the IDAS, I think.
Yeah,
exactly.
So I think the context in Europe is quite complex. I know that the EU Health Pass, their green certificate, as they call it, is using a COSE-based format. So COSE is an alternative to JOSE. Instead of JSON signing and encryption, it's CBOR signing and encryption. And And the solution they've chosen is kind of one where the credentials act as kind of bearer credentials, where they don't have that subject authentication. And so they have different sort of properties than the credentials that we just talked about. And we view them as sort of a parallel kind of path. It's not the worst thing in the world. There's certainly properties to that solution that are useful. I think the trouble with big governments building on things like linked data proofs is, like I just said, they're going into standardization this year, right? So for instance, for these large scale rollouts, especially related to things like COVID, they want to be able to build on what they perceive to be kind of stable infrastructure, and in many cases that's meant building on legacy formats, right? But there is like a very, I think, intense like community pressure to look at all the work that's going on and to consider, especially like you said, some of the privacy controls, because if we're not building towards that model from the get-go, we'll never get there, right? And it'll always be kind of a good enough sort of approach. So we can definitely, I think, explore a whole bunch of things about what's going on in the EU, how interoperable it'll be. But at the moment, like I said, we view it as sort of a parallel path, if that makes sense. One with different properties. Yeah. Any other thoughts, questions? Okay.
No, I just want to thank you for your time. It was really, really, really interesting. Learned a lot. Need to digest this now. Thank you.
I'm glad. Thank you all. Appreciate your time, and it was great meeting you. And hopefully I'll catch the next one.
Yeah, thank you very much.
Thank you very much.
Yeah.
Yep.
See you all.
All right.
Bye-bye.
Bye-bye.